Today we're going to be talking about exponents. We'll have some examples to look at together. We'll pause and try practice problems, and then we'll move on to the classwork. So properties of exponents are just talking about just different rules to remember when we're working with exponents. So when we have something like this, you want to know that the big number is the base, and the small number written up and to the right is the exponent. You may already be familiar with these terms. Exponent. And so the exponent of a number is basically telling us how many times we're multiplying something. So if we take that again, 5 to the second power, that's saying take the number 5, multiply it 2 times. So 5 times 5, which is 25. So the first two properties we're going to talk about are very simple. There's not much to them. It's just basically saying the first one is what happens when we have something raised to the 0 power, and also the second one, what happens when we have something raised to the first power. So whenever we have something raised to the 0 power, it equals 1 always. So if we had 10 to the 0 power equals 1, negative 15,000 to the 0 power equals 1. And anything raised to the first power is always itself. So 2 to the first power, that's just saying you have 1, 2. 7 to the first power equals 7. So it also goes the same way, or it also goes in reverse. So if you're just given a number like a 2 and there's no exponent written, now you know that it's actually a 1. Same thing down here. If you're just given a 7, there's no exponent written, you know it's actually a 1. So anything to the 0 power is 1. Anything to the first power is itself. You might wonder why anything to the 0 power is 1. And I think I have something of an explanation, but we won't go over it together in this video. We can maybe go over that together at a later time, maybe later this week. So now we're going to go on to two properties that are a little bit more involved. One has to do with when we're talking about multiplication, and one for when we're talking about division. So let's start with multiplication. And these are things you'd probably want to have written down in your notes. So let's first start with this multiplication property, multiplication rule. This says that if you have the same base, again, base is the big number, or it can be a letter to a variable. If you have the same base and you're multiplying, you can add the exponents. They're both a's, we're multiplying, so we add the exponents, it becomes m plus n. So sometimes you'll see it written like this with everything as a letter, just to kind of show you the general format. But if we look at an actual example, it might look something like this. 3 to the 4th power times 3 to the 6th power. We'd say, okay, they have the same base. They're both 3's. We're multiplying, so we can add the exponents. So this would be 3 to the 4 plus 6, which is 3 to the 10th power. And so you want to keep in mind, if this was 3 to the 4th times, let's say 5 to the 6th, we can't do this rule because they need to be the same base. In this case, now they're different, so we wouldn't be able to apply this property. Let's look at one more. Let's say we had x to the 3rd power times x to the 8th power. We see we have the same base. They're both x's. So this would become x to the 3 plus 8, which would be x to the 11th. So like we said, it's okay if the base is a letter, a variable. Don't let that throw you off. Same thing, it's the same base. We're multiplying, so add the exponents. Now, before we try some practice, let's look at this division property, which is basically the same thing, but with division. So this is saying if we have a to the m power over a to the n power, that's going to be a to the, what do you think? What's going to go here? Here we're multiplying. We had m and n, so it became m plus n. That was when we're multiplying. Now we're dividing. So take a guess what you think it would be here. It's going to be subtraction. The top one minus the bottom one. So a to the m minus n. So an actual example problem might be something like, let's say 5 to the 8th power over 5 to the 2nd power. Again, they need to have the same base. So in this case, they're both 5, so that's good. And so we do 5 to the 8 minus 2, which becomes 5 to the 6th power. And you can keep going from here. You could say, what is 5 to the 6th power? But for now, we're not going to do that. We'll get there. Let's look at one more. Let's say we have 9 to the 12th power over 12 to the 9th power. What are we going to do here? Well, first thing, we need to look at the bases. Remember, they need to be the same base. But here, red flag, now they're different bases. One's a 9, one's a 12. So we can't apply this division property. We wouldn't be able to approach this problem with that. So in this case, we just say something like cannot apply this property or something. Or we just wouldn't do anything with it. So let's move on to practice. So these practice problems, you want to make sure to follow along with. Normally, when we're in class together, you would copy these problems down and try them out. You'd get participation points just for copying them down. And so let's go. Let's try some. So these ones are going to be combining either using that multiplication property or the division property. We'll just put a couple up here. All right, so let's pause the video here and go ahead and try these out. All right, so let's take a look at these. So first one, we're multiplying. We see we have the same base. So we add the exponents. Comes 2 to the 3 plus 6, just 2 to the 9th. Second one, we look at our bases. They're both a C, so that's good. We don't care that they're letters, that's fine. We're multiplying, so we add the exponents again. We get C to the 8th. And last one here, we're dividing. We want to make sure to check the bases. They're both the same. We're dividing, so now instead of adding, we subtract them. We get 3 to the 6th power. Now, another thing we're going to look at is what we maybe can call applying exponents to quantities. Oh, wait, there's one more we want to talk about first, which is the power property. So basically, so far, we talked about what happens when you have a 0 exponent and 1 exponent. Then we just looked at multiplication and division. Now we're going to look at what happens when you have a power raised to a power. So that'd be like if you had this. a to the m power raised to the n power. Exponent raised to an exponent. And a lot of times you may see this written differently, especially in computers. It may be formatted a little bit differently. You may see it written like this. So in one case, you have a power raised to a power, like this one's even higher up than the m. But over here, they're written on the same level, but one's just outside the parentheses showing that you're raising it to the m power, and then afterwards you're raising that to the n power. So this is power raised to a power. So whichever way that it's written, these are both saying the same thing. So an actual example of this would be like if we had 8 to the second power raised to the third power. So what do we do in this case? It's going to become 8 to the, what do you think? Well, power raised to a power is going to tell us to multiply. So this is going to become 8 to the 6th power. 2 times 3 gives us 6. Let's look at another one. Let's say we have x to the 5th power raised to the 7th power. That's going to become x to the 5 times 7, which would be x to the 35th power. So that's the power property. And last thing we'll talk about here is what we were starting to mention before. I don't know if we would call these properties of their own necessarily. We might. But we're looking at here what happens when you apply an exponent to either two things being multiplied or more, or things being divided. So what do you do in this case? Well, it's kind of like the exponent gets distributed to everything on the inside. So this m goes to every factor here. This m goes to the top and to the bottom. So here this would become a to the m times b to the m. This one here would become a to the m over b to the m. So an example of something like this would be like if we had a, let's say we have 3x squared raised to the third power. So we have two things being multiplied on the inside of the parentheses. And this is maybe getting a little bit trickier here. We have one thing being multiplied with another thing. So we know this 3 needs to go to both things on the inside. So we're going to have 3 cubed. And it's still multiplication. And we're going to have x squared to the third power. So 3 cubed, that means 3 times 3 times 3, that's 27. And we just talked about the power property. We have x raised to the second power raised to the third power. 2 times 3 gives us 6. This would be 27x to the 6th. Let's try another one. Let's say we have 2a to the third raised to the second power. So like we said, if there's an exponent outside parentheses, it needs to get applied to all the factors on the inside. We have a 2 multiplied with an a cubed, so it needs to go to both of those. So we're going to have 2 to the second power. And when things are just next to each other like this, 2a cubed, again, that means 2 times a cubed. So that things don't get too messy, we'll just write in that multiplication symbol instead of just squishing it all together. And we have a cubed raised to the second power. We know that 2 squared, that's saying take the number 2, multiply it 2 times. 2 times 2, that's 4. And we see here that we have a power raised to a power, so now we know to multiply those. 3 times 2 gives us 6. So we have 4a to the 6th. So let's try practice. And we'll leave this example up here for the moment. This is probably the trickiest thing we've done so far here. Let's say we have we'll use an exponent of 2 on the outside again so that things don't get too tricky just yet. So go ahead, let's pause the video here and try this one out. All right, so let's have a look together now. So this time it's a little bit different in that we have 3 things being multiplied: 5 times an x squared times a y cubed. And this needs to go to all of them like we said. So this is going to become 5 squared times x squared raised to the second times y cubed raised to the second. 5 squared, that means take the number 5, multiply it 2 times. 5 times 5, that's 25. Here we have a power raised to a power, so multiply those numbers. That's going to be x to the 2 times 2 is 4. And then 3 and a 2, multiply those, y to the 6th. And now we don't need these multiplication symbols. We can just squish it all together. And if somebody sees it like this, they'll know it's being multiplied without having to write those symbols. So 25, x to the 4th, y to the 6th. So we didn't go too much into, and we'll leave off the division one for now. We'll maybe spend some more time with that, or leave it as a sort of bonus question for the upcoming classwork. We didn't go too much into why some of these properties work. So let's just look at real briefly before we get to the classwork. Particularly, we'll look at the multiplication property and the power property. As we can remember these rules to apply, but it can also help to understand or have a little bit more information about what's going on behind the scenes. Why do these properties work? So multiplication property, that's like we said, if we have 2 squared times, or sometimes it's even easier to think of with variables. Let's say we have x squared times x to the 3rd. So what we were saying earlier is that exponents tell you how many times you're multiplying the base. So this is saying we have 2 x's being multiplied. This is saying we have 3 x's being multiplied. And we can just drop down this multiplication symbol. Now count up how many x's we have being multiplied. 1, 2, 3, 4, 5. So now we know that if you multiply x squared times x to the 3rd, we get x to the 5th. And we could have used our property to shortcut that. We could have said x to the 2 plus 3, which is x to the 5th. This is just saying we have 2 x's and we're getting 3 more x's. Now we have a total of 5 x's. Power property, let's say we have x squared raised to the 3rd power. What does this mean? Well, again, we're going to apply the same thing, which is that we know exponents tell us how many times we're multiplying something, the base. So here we're taking x squared and raising it to the third power. That means we're multiplying x squared 3 times. And then we can break it down further because we know that x squared is x times x. Each one of these is x times x. And they're all being multiplied. So now how many x's do we have being multiplied together? 1, 2, 3, 4, 5, 6. So now we have x to the 6th. Again, we could have used our power property here, which says x to the 2 times 3, which is x to the 6th. We multiply because this is saying you have 3 groups of 2x's basically. 1, 2, 3 groups of 2x's. So to wrap your head around this a little bit more, you might need to spend some time thinking about it, but hopefully that provides at least a little bit of an anchor in your mind for why some of this stuff works. So at this point, this will be the end of this first video. Go ahead and start working on classwork 1A, and then we'll have a second video for classwork 1B to start when we're ready.